All right, let's get started. Welcome all. I want to start with a question for the audience. If you had to bet on one single programming library or framework that is out there today that's going to benefit the most from this wave of agentic development, what would that be? I have a little bit of an out-of-the-box take on this, which I'll share at the end of the webinar, but feel free to think about this, or you can drop it in the chat. I'm not going to look at the chat just yet, but you can all go crazy in there. So with that question posed, let's get down to business. My name is Kent, and I lead our applied AI team here at Retool. And today is going to be all about agents. We're going to define how an agent works, and we're going to actually build one inside of Retool. We're going to talk about some comparisons and trade-offs that you might make by using different platforms. And at the end, I'll share a few takeaways that I have from building these systems myself. As a quick note, we've received an overwhelming amount of feedback since planning this webinar, and we've had a lot of people reach out to specifically request examples of how to build agents inside of Retool, because they weren't sure that that was something that was possible. So we've shifted our content a little bit to make that more of a focus, but we're still going to discuss other platforms and lots of general ideas as well. We should have lots of time at the end for any questions, so feel free to pop them into the chat as we go. We have some folks in there answering live, and I'll save a few for discussion at the end. So whether it was Salesforce launching Agentforce last year, OpenAI launching Operator last week, Satya Nadella talking about the end of SaaS because it's going to all be agents, Zuckerberg's saying how there's going to be billions of AI agents in the world, or really just the continued progress of tools like AutoGPT or LangChain, who've been working in this space for years. Agents seem to have really formally cemented themselves in the AI zeitgeist last year, and I have every expectation that in 2025, agents will continue to be one of the main topics of AI development. Now at Retool, we're focused on building operational software that hundreds of thousands of companies use to do everything from planning the Olympic TV schedule to allocating GPUs across their customer base, to organizing the launch of the next season of your favorite show on just about all the streaming platforms. And our customers build custom software on top of our platform to solve problems that are specific to their businesses. So with the rise of agents, it's natural that a lot of the development teams that are already building on Retool are asking the question, how should we think about building agents to work with the tools that we already use? These are conversations that I've been part of for a while now, and I've also implemented a few agentic systems that we have in production at Retool. And I was asked to share our perspective on building these agents. Now, due to the type of software that we tend to work with at Retool, I'm mostly going to be focused on teams building agents to automate work internal to their company. These might be considered verticalized internal B2B agents. And that's not to say that if you're interested in building agents for consumer use cases, this won't be valuable. But there might be additional considerations or different trade-offs you make in those situations that won't necessarily be a focus here. So there are hundreds of different agentic frameworks, tools, and platforms that you could choose from. And things are developing very quickly. It feels a little bit like front-end web development did in the late teens, where it felt like there was a new front-end framework coming out every month. And I think there might also be a little bit of that same framework fatigue that people are starting to get at the idea of learning yet another paradigm. Except with AI and with agents, it's moving much more quickly than front-end web ever did. And also the potential impacts that agents could have is so much higher. So the ground is shifting under our feet, but at the same time, our leadership is asking us to implement these agentic systems and to try to realize some of the enormous potential that they promise. What should we do? What I'm going to do today is to take a little bit of a step back and to look at these agentic systems from first principles. This is going to allow us to judge what's available on the market today, but importantly, have a framework to better understand the landscape as new tools are inevitably announced this year and into the future. Because once we understand the basic building blocks and how they can be composed to build agents, I hope it'll demystify some of the decisions we need to make as builders. And in many cases, make us realize that we can build these tools with a lot of the same technology or patterns that we're already familiar with, rather than being uncertain about mostly marketing terms for things that we already understand, if only we used different language. So the goal of this talk is to really talk about building an agentic system. And to start, we're going to get on the same page about some terminology. Specifically, we're going to build up from the augmented LLM to a Gen AI workflow, to an agentic workflow, and finally, to a full agent. So let's define an agent. I'm going to get a little bit pedantic here because I think clearly communicating these ideas is important to avoid misunderstandings about functionality and implementation. And there are some subtle but important differences between the things that we're going to talk about. I suspect many people watching this will have read Anthropic's Building Effective Agents blog post. I'm going to use a few terms that are defined there as a starting point, but I'm going to take one idea a little bit further in my definition. If you haven't read this, I'd recommend go finding it after the presentation. It's definitely worth a read. So let's build up to an agent. Of course, we start with the LLM. And LLMs in isolation are not very useful, as they have no ability to interact with the outside world. And so in order to fix this problem, we typically give them tools. Tools so they can interact with other systems, whether that's calling APIs, searching the web, or executing code in a sandbox. We also give them state or memory so that they can maintain knowledge between multiple calls to the LLM. And we provide data or context, usually in the form of a vector database, so that they can access more up-to-date information than what they were trained on, or data that is specific to our business or to the task at hand. Following Anthropic's lead, let's call the LLM with the tools and the state and the context the augmented LLM. And moving forward, when I represent this LLM in the purple box, we'll assume I'm talking about the augmented LLM. So now that we have our augmented LLM, let's put it to work as part of a business process. Let's imagine a customer support tool where we might get a message from a user. We might look some information up about that user from our database. We'll pass that into an LLM, and we'll ask it to suggest a response. This is not an agent. This is what I might call a Gen AI workflow. Basically, it's a predefined process where the LLM is involved at one or more steps to generate some or all of the final output. And just because this system isn't an agent does not mean it's not useful. In fact, many content generation use cases will use an architecture like this and be quite successful. And this brings me to one of the sort of first points I want to make. Not all systems that include LLMs are agents, and systems that aren't agents might be the best solution for the problem at hand. Again, going back to Anthropic's recommendation from that blog post, start simple and see if we need more complex architectures. But moving up the complexity chain a little bit, that was a Gen AI workflow. Let's have a look at an agentic workflow. Imagine a business process where the LLM isn't just generating content, but rather it's actually generating a decision. Back to that customer support example, we could imagine a simple tool that for every message that came in, the LLM decides whether or not it should be routed to a billing inbox or to a technical support inbox. This is what we call an agentic workflow. Again, not a true agent, but it's getting more agentic because the LLM is deciding what step we take next. A more formal definition of an agentic workflow would be a system where the LLM informs the control flow of the application. So another example that is not truly an agent, but still very useful for certain tasks, useful for routing requests, handling support deflection, and a lot of general business process automation. But this brings us to an agent, which I would actually consider a sort of more specific version of an agentic workflow. An agent is a system in which the LLM is not only responsible for managing the application's control flow, but specifically for determining the application's termination point. In an agent, the LLM decides when the program terminates. And I find this to be a clearer way of thinking about these systems rather than just saying that they're autonomous. They are autonomous, but in the case of the applications that we're building, the important characteristic of the autonomy is that the LLM decides when to stop. An agentic workflow has a defined starting point and ending point. It may take different routes to get there, but we know it will get there. An agent does not have a predefined ending point. This is potentially a very valuable architecture because it's so flexible and open-ended that it can solve complex tasks. But it comes at potentially a big cost. We're handing over so much control to the LLM that it can easily get stuck in loops. It can burn a bunch of tokens, it can waste other resources. And importantly, I think it can just provide confusing user experiences to the people who are interacting with them. That's not to say that this architecture is particularly risky. You know, the agent is still operating within a pretty explicitly defined environment. It's only, using the tools that we give it access to, so it's not going to go take over the world or anything, but it can fail in hard to fix ways. So we've defined these three categories of applications. We have the Gen AI workflow, where the LLM is involved in generating some or all of the final output. We have the agentic workflow, where the LLM influences the application control flow. And we have the agent, where the LLM determines program termination. So agents are exciting, and there's a ton of potential. But actually, now that we have these three definitions, I do want to step back and touch on the agentic workflow. I think there's an enormous amount of work that is done by people in front of computers today that can be accomplished with this simpler framework. A lot of the work that we do as part of normal business processes can be represented by taking a predefined set of deterministic steps and coupling them with some human-level judgment from the LLM. We don't always want the dynamic nature of an agent. And in fact, in some cases, we want the simpler, more deterministic agentic workflow. An agent might be useful for doing some open-ended tasks like research or debugging. But once we've developed a standard playbook of processes, whether that's in customer support or in product development or running payroll and finance, we want to encode those processes into a deterministic workflow and just use the LLM for the human level judgment at a few key steps. And so it's tempting to go build a full agent, but a ton of automation can be handled with the agentic workflow. And frankly, they're much easier to build, to reason about, to maintain, and to debug. So now that we have this framework to think about agents within, we're gonna have a look at one. We're gonna have a look at one that's built in Retool. And we're gonna do this with a focus on the building blocks that you really need to implement this from scratch. Because once you've built it from scratch, you have the ability, I guess, to implement it with tools that you're familiar with. It's gonna be much easier to judge what other platforms are offering and what trade-offs might be right to make in the particular situation that you're in. What are we going to build? We're going to build a pretty classic React agent here. So React is a particular cognitive architecture for solving dynamic problems. It reasons about the steps it needs to solve the problem, then it acts on those steps, react. And when I say cognitive architecture, I'm referring basically to the patterns of instructions and the mechanisms for interacting with its environment that we're going to give to the agent. The same building blocks can be used to build a bunch of different cognitive architectures. So the React piece isn't necessarily what's important here, but rather it's those building blocks that we need to make it work. So I'll demo this first, and then we'll look under the hood and see how it works. And this agent is sort of generally set up to be like a business intelligence or data assistant. It can use tools to create SQL queries. It can run them against our data warehouse. It can generate visualizations. It can ask follow-up questions to humans, and it could send Slack messages. Here's the UI that we're going to be looking at to show this agent. And here's the type of question that we could think about asking. So we asked a question, can you chart our user signups by month from 2021 to 2024? And when we send this message, we're triggering our agent, which is built in a retool workflow. And we can see the steps that the agent is taking in order to solve this problem. The first step that the agent took was to use the text-to-SQL tool in order to generate the SQL that it needs to answer this question. The next step that the agent took was realizing it had the SQL query. It needed to go execute this query against the database. Now, I'm sure we can see it thinking here, the last step that it will decide to take is to use its data visualization tool in order to actually represent the information that it got from those two previous steps. And as is the nature of live demoing and everything, particularly with AI, it is a little bit slow. There we go. So this is the chart that it generated by using the generate visualization tool. We can see the signups that we've had for the last 3 years. So this isn't a predefined process, right? We never said use tool A, use tool B, and use tool C. The agent, that cognitive architecture of the React agent, chose the right next step to take at each of these points. So let's have a look at how this works inside of a retool workflow. And this is the retool workflow that whenever we send a message in that front end, we're going to be triggering. I'm going to kind of start in the middle of this workflow, but we'll explain every step. But we're going to start here with this sort of most important part, I think, which is the core React step, which is our LLM call. We can see what we're doing is for every run, we're going to pass in the previous steps and the request from the user. The system message is giving the LLM some general instructions about how to behave. Here we're defining all of the tools that the LLM might have access to. So we can see the text-to-SQL tool. We have our tool name, our tool description, input and output for each of these tools. We're going to give this LLM, again, some general instructions on how to behave, which is taking one step at a time and using the previous steps to inform your choice. And importantly, when the LLM decides that it's complete, we're telling it to return this final response. A few other things in here with the prompt that we don't need to worry about, but when we run this query, we then go parse the result. We get the LLM to return XML, so we need to parse that into a JavaScript object. That's just basically a JavaScript function there for all intents and purposes. And then we check, do we have a final response based on the LLM's decision? If not, we go and reroute to our potential tool choice. So here, again, if the LLM decided, as we saw in our example, that it wanted to use the text-to-SQL tool, this condition would be met. This would evaluate to true, and then we would go run our text-to-SQL tool. Our text-to-SQL tool is implemented as a retool workflow itself. It's a retool workflow that takes in some natural language and returns a string of SQL that is appropriate to be run against the sort of correct schema of the database that it might be connected to. Finally, we sort of collapse down the result of whichever step may have been run. And then we go save that state to our database. So this is essentially memory inside of the agent. We're keeping track of the previous things that it has done. And then importantly, this is where the main sort of agentic loop happens. The workflow calls itself, and so then it restarts. And in our example application, each of these gray boxes that is represented here is one single step. It's sort of one full run of that workflow. And the workflow calls itself again, and it restarts. And so it took 3 steps to solve this particular problem. So once this workflow calls itself, let's go back to the start and have a look at what the full process might look like. When we first trigger this workflow, we go get our previous steps from our database, and we get the message from the user from our database. These 2 blocks are just formatting those previous steps and messages as XML so that we're consistent in sort of the way that we're passing this to our LLM. And then we're back to our React step where the LLM is going to decide the next step to take to solve the problem. Assuming that we're on our last step here, and the LLM did indeed return a final response, this is that block that really makes this an agent, because here we have the LLM deciding whether it's going to terminate or if it's going to keep running. And if indeed it does decide to terminate, then we'll follow this path where we grab the most recent messages from the thread and then write back to the thread to update with a final answer, mark the messages complete, and terminate the application right here. So that's a good description of sort of implementing that React agent architecture here inside of a retool workflow with the tool use. And I want to focus on a few particular parts of this agent, a few particular parts of this build and how we did that. The first one I want to focus on is that state or that memory piece. We want to add state to our agents so that they can maintain context across multiple calls to the LLM. Honestly, in a lot of implementations, this is just another way to say passing the previous messages in from a particular thread. We need to pass those previous messages in so that the LLM can understand the whole conversation, the context, the previous steps that it has tried. So in our workflow, we're reading and writing to a retool DB table, which is just a Postgres database. This is what we can see on the screen here. And this has some trade-offs. On the one hand, it's flexible, right? We can make a Postgres table store just about anything. It's persistent, and we can keep track of the historic state of the agent. It allows us to step back in time and see a history of all the conversations in each step. And this can be handy for debugging or for running evals on in the future. And essentially what we've implemented here is a hot path short-term memory store for our agent. It's hot path because it's happening as part of the application logic, and it's short-term because in this case it is thread specific. But there's a lot of different sort of state or memory paradigms that different frameworks use. Here we can see 5 different ones from CrewAI. So short-term and long-term memory generally refer to either thread-specific messages for the short-term memory or information that can be accessed across threads, long-term memory. The entity and contextual and user memory here are different constructs for essentially storing different types of data. And at the end of the day, what we're really talking about when we're talking about memory or state is storing data and then passing it into the model. So if you have the ability to read and write to probably both a structured database and a vector database, you can build your own version of a lot of these different kinds of memory or state. One thing to keep in mind is performance. With the implementation that I just showed, we're reading and writing to a database, and that's a pretty slow operation compared to using an in-memory store like you'd get from LangGraph or CrewAI. The latency of querying a database is usually relatively small compared to the latency of a model, but if you are optimizing for performance, this is definitely something to keep in mind. I think the key here is flexibility, right? The way that you need to build memory into your agents tends to be quite application specific. And ultimately having the control over how you implement that, regardless of what tool you use, is going to prevent you from getting stuck when you're building. Next up, let's talk tools. So tools are what allows our agents to interact with other systems. In the example that I showed, we defined our tools with XML, and we implemented them as retool workflows. The tool definition is like a function signature that we provide to the LLM. And if the LLM decides to use that tool, we pass the structured arguments it provides back to the function, in this case, the retool workflow, that actually goes and executes the task. So on the one hand, doing this with retool workflows is great. It's pretty flexible. And with retool workflows, we tend to have access to a bunch of internal data sources that we can use as tools. But on the other hand, it's manual to have to define these tools essentially for every system that we want to integrate with. And this is where leveraging a Python library can save us a lot of time. Both LangGraph and CrewAI have built-in and community-supported tool sets that are predefined and available for use. For most common actions, using these existing tool sets is going to be handy. And for situations where tools don't exist, for the most part, they're relatively simple functions. So in all platforms, including Retool, you can essentially write them yourself. There's also a protocol from Anthropic called the Model Context Protocol. This is essentially like a standard interface for connecting with third-party tools, which I think will go a long way reducing boilerplate in the future. Yet to see sort of exactly how much is going to be adopted. One other note on tools and flexibility. We have customers who are implementing their tools as a retool workflow triggered via a webhook. And then they're calling them from frameworks like LangGraph. But we also have customers who are doing the exact opposite. They're defining agents inside of retool workflows, but hitting tools that they're hosting outside of Retool. And both ways work. Basically, these teams are choosing what makes the most sense for them. If you potentially have agents running in a bunch of different environments, but want to maintain a single set of tools that you're hosting, it might make sense to do that outside of Retool, so it can be accessed from all these different systems. But there are other teams who are experts in Python, but don't want to worry about hosting web services. Building tools and retool workflows has been a great fit for them. I would appreciate you letting me know in the chat, actually, if connecting with these sort of commonly used tool sets or leveraging MCP is something that you'd want to use inside of Retool. They're both features that we're considering adding right now. Next up is human in the loop. So we didn't see this in our demo, but the agent that we built in Retool, plus essentially every agentic framework like LangGraph and CrewAI, have the ability to pause and to ask a human for input on particular steps or before particular steps. And in most cases, this is actually implemented by sort of emitting a string, which is the message, and asking the human to respond and parsing their message and passing it to the LLM. And for simple cases, this is fine. But if we're building an agent as part of a critical business process, there might be more control that we need or would want to think about at least. We have some customers who are combining agents built in Retool workflows with our human in the loop feature. It's a beta feature right now, but pretty widely used in a testing environment today. And so rather than just asking for a message from the user before continuing, what this allows you to do is create an auditable permissionable, customizable task that would need to be approved by one or many people and certain permission groups before continuing the execution of the agent. And so this combination of agents plus proper human-in-the-loop tasks does enable some compelling business processes to be automated inside of Retool, because it gives a lot of confidence that the right approvals will be given to an agent before it continues. And so if you're building agents yourself, regardless what platform you're on, it might be a good idea to think about how you're going to integrate with your existing approval processes or tools, systems, software that you use at your company right now, as your agent maybe evolves from a proof of concept to the production application. Lastly, I want to talk about UI, which is not always something that we talk about when we're talking about agents. A lot of agent frameworks or libraries, they're Python packages, right? They're deliberately backend systems. They're not trying to give you a full stack app, and that's fine. Of course, if you ever need a super custom UI, you can build it yourself. A lot of tools do give you an out-of-the-box chat UI. So this is really handy. And chat is still the primary modality, I think, that most people are using to interact with agents. There are other tools like the Microsoft AutoGen, as an example, who do give you a low-code way to build a UI. And I think, at least for a lot of the folks that we work with, this ability to build a custom UI on top of your agents inside of Retool is a huge plus. And actually, of course, you can build that custom UI in Retool on top of an agent built in any system. Ultimately, it comes down to the fact that humans are still pretty involved in these flows and in these processes, and humans mean UIs. I do think that in the future, we'll start to see agents embedded right into the business tools that people are actually already using, rather than going to a specific chat application to ask an agent to accomplish a task. As a note, another benefit of the UIs, which I think is important while agents are still a relatively new type of software that we're building, I've personally found that explaining how agents works, even if we're doing it in a visual environment like Retool Workflows, where we can visually represent the whole flow, it's a lot less effective than just showing someone an agent in action, or even better yet, letting them play with it. So being able to customize the UI around your agent does allow you to sort of experiment quickly and potentially get buy-in for some of these projects. So we talked about state management or memory, talked about tool use, talked about human in the loop, and we talked about UI as some of the important building blocks to keep in mind as you're potentially exploring agent platforms or building something yourself, as these things need to integrate with real business processes. I want to wrap up with a couple important takeaways. So we defined our GenAI workflows, our agentic workflows, and our agents, where the agents are the systems where the LLM controls program termination. But agentic workflows are simpler to build, they're simpler to reason about, and simpler to debug usually. And I think there's an enormous amount of business value that can be delivered just with the agentic workflows before we even need to worry about building agents. Secondly, we showed building that React agent in Retool. And I think it's really cool that you can do stuff like this in Retool, but frankly, the secret here is that you can use any system that gives you the ability to call an LLM and implement some logic to build an agent like this. You can implement these architectures anywhere. And I would focus more on the tools that integrate with your data, or maybe with your existing systems, or maybe with your skills, more than I would on learning a bunch of new frameworks. By understanding that architecture rather than the framework and having the ability to build these things from scratch yourself, I think you're better able to judge, when this next wave of agent tools comes out in the space, as I'm sure it will this year, and make your own trade-offs. And I think that's really the real solution to this builder's dilemma, is having the ability to understand what's really happening on the ground level yourself, and then deciding to apply a tool. Lastly, I want to get back to that question that I posed at the very start here, which is, what single library or framework is going to benefit the most from this wave of agentic development? And my kind of joke answer to this question is React Flow, which is a library for building node-based UIs on the web. Because when you look at almost any product in this space, it fundamentally boils down to a graph of nodes. And React Flow really has that market cornered. I think we'll see a lot more agents in 2025, and I think we'll see a lot more React Flow visualizing them on the web. So that is the end of our prepared content. Let's get to some questions. I see one here, which is, what are the key factors when deciding whether to build an agentic workflow versus an agent? Maybe as a bit of a rule of thumb, sort of the degree to which the process is open-ended would be one thing to think about. And if you're uncertain about that, I mean, I would think about, if here's basically what we apply internally. If we have work that is being done by humans right now, where we can essentially define that process, we have step A, step B, step C, we have a decision point, and then we go step D, E, F, and so on and so forth. If we can express our process in a framework like that, we're going to go agentic workflow. Again, for the reasons I mentioned, frankly, it's simpler to build. Right now, these sort of open-ended exploration problems, and in a lot of cases, I think the way that I've seen it be really applied is for a lot of like data exploration tasks. And so that tends to be a place where agents make sense, because people are asking unique questions all the time, so it's therefore open-ended. But as an example, let's say that you need to generate a particular report every month. That is a defined process. And so I think we would not want to choose an agent to do that task, because essentially every time it runs, it needs to go figure out the process, again, the steps that it's going to take to solve the process. And most of the time, if we build a good agent, it's going to do that well. But it's unnecessary work, and it's an unnecessary increased risk of it failing. Whereas if we know the process, let's encode the process and then not worry about that. I see another question here about prompting tricks or ways we can get the LLMs to make more consistent decisions. What I would recommend doing is reading OpenAI has a really good sort of prompt guideline summary in their docs. I think Anthropic does too. I would start with that, and I would read that. That's going to be more comprehensive than sort of any answer that I can give here just in a few minutes. But maybe the sort of meta answer to that question is around the word consistent, and what we really mean by consistency, and importantly, how are we measuring the consistency? Because if we're building something and we are testing it, just as one developer, as a team of developers, that is that's a pretty non-systematic way to actually test our agent. It's kind of like this vibes-based prompt development, and that is almost definitely not the answer. The answer there to actually first track consistency and then allow us to address it is, right now, seems to be to run evals. And so basically every time you iterate on your prompt, you want to run it against a set of test cases that are known, such that you can decide, has your change actually improved the outcome or not, in a systematic way, rather than in for this one question I came up with, it feels a little bit off, or something is a little bit different. That is what I think generally it would be good to avoid. Okay, I see a question about deciding when a particular set of functionality should be an agent of its own versus simply a tool that another agent uses. And I think this goes back to those sort of three different types of applications that we talked about here. And in practice, what we want to do is we do want to compose a system that includes probably all of those different types of applications. And so let me just pop back to that slide while we look at this. We could think about even a simpler version of an application here, which is just a function call, right? And so that would be the simplest version. And some tools are just function calls. And we can implement those as tools. That's pretty obvious. We could, though, also build that tool interface on top of any of these other types of systems. And so the question as to whether you should build the tool as an agent or an agentic workflow, it kind of just comes back to the encapsulation question around what is the type of specific problem that you need to solve in that context, and does that problem need, or sort of what architecture is appropriate for that problem. But if we then zoom out to our whole system, indeed, I think we do have a world where we have an agent who may have the ability to call many other agents. It may have the ability to call many other agentic workflows. It may call many Gen AI workflows, and it probably calls a bunch of just pure functions as well. And this is going to all be interconnected. And so rather, as far as specifically answering that question, I'd focus on like the core problem that set of encapsulated functionality is going to solve. If it's an open-ended problem, maybe you do need to implement it as an agent. If it's a much simpler problem, maybe we can implement it as just a function call, essentially a tool. Question about DeepSeek, which is, of course, the topic of the day in AI. And the question is, forgive me, do you think that reasoning models will reshape the way that we build agents or agentic workflows? And I think this is really interesting. I mean, so on the one hand, I saw a great meme recently, which is like talking about the people talking about DeepSeek and having their opinion, which is really just an opinion that they read on the internet. I'm not going to pretend to be an expert on these models, but I do think that it depends really how integrated into the model, into these reasoning models, the tool calling is going to get, right? I think that fundamentally is going to determine whether we need to build these systems around the LLM in order to handle all of this logic, this cognitive architecture, or if the models themselves, these reasoning models, are going to continue to expand kind of behind the API, such that as developers, we don't need to worry about that. And maybe we don't need to worry about it at all, or maybe we just need to worry about it to the degree that we sort of pass in the functionality, or the tools specifically that we want the reasoning models to call. But I don't know. I think it's going to be a fun year, basically seeing the answer to that question develop. Just looking at some other questions here. So there's a question about debugging agents. The question is, how do you think about debugging agents when your code has an error? You get a stack trace, it throws an error message. But when an agent behaves unexpectedly, how do you think about noticing and correcting that sort of issue? I think the debugging of an agent probably tends to be pretty specific to the platform that you're going to be building that agent on. I'll show you an example of how I might think about doing that in practice with this agent here that we showed. As we mentioned, every step that this agent takes is a workflow run. And so as I'm building something like this, we are indeed, of course, getting errors, getting issues, having to debug this. And what I'm doing is I'm walking through these particular steps. So we can see this was the step in this workflow where we made the SQL query, and we're looking at the data in and the data out, and essentially boiling it down to what exactly is being provided to the model at every one of these steps, and what is the response that it is getting, and being able to, I think, have this record of every step running and to be able to go back and debug is helpful. Again, this will look different in different tools that we're using, but this is what I do in practice here. Let me just see, did I answer that full question? Yeah, in my experience, the other thing I can share, I guess, here is this sort of React architecture around getting the LLM to share its thinking as well, and to save that alongside the actual tool call or step that we decided to do, has tended to be a pretty helpful debugging tool, because it's almost like the system explaining itself. And so if it says, I chose to do X because of Y, and that turns out, in your opinion, to be the wrong choice, you have an explanation of at least why it chose to do that, and then maybe you can go back and address that incorrect decision-making, either in the prompt or in the context and data that you're passing in. Okay, so I think that is where we are going to end things for today. Thank you so much for joining. I think we'll be sending out a follow-up after this. Always open to chatting about this stuff. I'm kent@retool.com if you want to learn more. Otherwise, have a great week. Bye-bye.